Welcome back to the Cave of Science and another running scientist production, and we're going to balance a few examples of chemical equations. So let's start off, let's just jump right in. So our reactants for this one is sodium nitrate, and we are going to combine that or have a reaction with lead oxide, and that's lead 2. And our products are lead nitrate and plus sodium oxide. All right, so there is what we have. From the previous one, my little hints on balancing these, notice we have the nitrate polyatomic ion on both sides of the equation. So I like to put those in parentheses. It just visually helps me to see that a little bit easier. There's no magic formula where to start. Fairly obvious here. Excuse me. We have 2 nitrate ions here, and we have 1 there. And again, we can only use coefficients. So I'm going to put a 2 in front of the first, the sodium nitrate here. Now, when you balance these, this is the distributive property. So I have 2 sodium, and I have 2 of the nitrate ions. And again, if you treat this all as one, many times it makes it a little bit easier to balance. So let's take a look at this. I have 2 sodium. I have a coefficient of 1 here, so 1 times 2 is 2 sodium, so that looks pretty good. Again, I have the nitrate ion, so 2 times 1 is 2 nitrate ions. Coefficient of 1 here, there's nothing there, it's understood to be 1. And in parentheses, I have 2 nitrate ions here, so that one's looking pretty good. I have 1 lead. Again, if there is no subscript, it's understood to be 1. So 1 lead, 1 lead, 1 oxygen, 1 oxygen. So this one's balanced. And again, the more you do these, the more you get a better feel for what's happening in these. And you're going to start seeing some things as you work through these very, very quickly. All right, so let's write another one here. Let's try another example. And there we go. All right. So let's try another example here. H2SO4 plus boron hydroxide, which is kind of a different compound, but it really doesn't matter. And this goes to boron sulfate plus water. Well, if you remember one of the hints I told you, sometimes when you see water, it is much easier, especially if you don't see water on the other side of the equation, you see it on the product side, but you don't see it on the reactant side, is to go ahead and break that down as HOH. So I'm going to rewrite this. And again, I'd like to put my polyatomic ions in parentheses when I'm balancing, just so it keeps me visually that I have polyatomic ions there, even if there's only 1. And I'm just rewriting this again. And I'm going to rewrite this as HOH. Hydrogen hydroxide, if you will. All right, from here, now I'm going to change the color on this. Let's see what kind of fun colors I got. There we go. So let's look at what we have here. Again, no magic place to start, and if one doesn't work, feel free to jump in and try something else here. All right, so let's see what we have. Well, we got one sulfate ion here. We've got three there. So definitely, maybe, whoops. Well, why am I doing that? Let's see if I can get an eraser on there. Let's see if I can erase that. Oh, it's not going to erase very well. All right. I'm going to put a 3 here. So I got 3 sulfates, 6 hydrogens. There's my sulfates are balanced. But my problem is I got 3 times 2 is 6 hydrogens. And I don't have any here. I've got 1 there. So I know I need 6. So let's go ahead and put a 6 in here. All right. So 3 times 2 is 6 hydrogens. 6 times 1 is 6 hydrogens. 3 times a sulfate ion, I have 3 of them. 1 times 3, I have 3 of them there. So I'm pretty good. So I'm getting closer now. And let's see, if I put a 6 here, I've got 6 hydroxide ions. Here I've only got 3. So it looks like a coefficient of 2. 2 times 3 gives me 6. And now the only thing left is the boron. So 2 times 1 is 2. 1 times 2 is 2. So that looks like it's pretty good. And again, if there's nothing there, it's understood to be 1. And again, it's really, you start getting a feel as you're working through these. You know, if something doesn't work, go ahead, change the coefficient and try something different here. But what you're going to start finding is things are going to start balancing out for you, so to speak. All right, so let's go on down and let's try another one here. So we got iron plus silver nitrate. And that goes to iron 2. And nitrate, there's going to be 2 of those. And we've got some free silver there. And let's go ahead and find. All right. Again, I like to put my polyatomic. Oh, I don't want that. Definitely don't want that brush size. There we go. I like to put these in parentheses here. So let's go ahead and take a look at this. So I've got 1 nitrate here. I have 2 nitrates. And again, the coefficient here is 1. I got 1 iron and I got 2 nitrates. So definitely I'm going to have to put a 2 here. That's fairly obvious. I'm going to have to do that. And let's see now. I have 2 silvers. I've only got 1. This is where it's kind of nice when you have free elements just to balance those last. I'm going to put a 2 there. So let's go back and look at this now and see how we're looking. I've got 1 iron, nothing there, it's understood to be 1. I got 1 iron, 1 iron, again, no subscript, understood to be 1. 2 silver, 2 times 1 is 2. 2 times 1 is 2, looking good. I have 2 times 1 is 2 nitrates. 1 times 2 is 2 nitrates. So I'm looking pretty good there also. So that one's balanced. And if I can drag this one down a little bit, let's try one more of these. All right, let's put in iron plus chlorine, and again, chlorine is one of the 7 diatomics, and we end up with iron chloride. Looks like it's iron 3. All right, here's kind of interesting. Looks fairly simple. Whenever you see I got chlorine with 2 of them here and I have 3 of them here, always go to the least common denominator. So the least common denominator between 2 and 3 is going to be 6. So I know I need a 3 here. So 3 times 2 is 6. So I need to put a 2 here. 2 times 3 is 6 for the chlorines. So I'm good there. 2 irons, very easy to do right here. Put a 2 in the front. So this one is also balanced. And again, you're using these coefficients. And really, again, as I mentioned before, you really got to work on just working on these, having some fun with them, and really think of them as a game. It's they're really not too bad. Once you start seeing some of the patterns here, they go along pretty easily. All right, so have fun. You'll be doing some of these in class, and we'll talk to you later.